Hello, Meteor.
Hello, Meteor.
Have you heard about the website called Discovery.com?
Discovery.com is my guidebook for life. I learned how to plant an herb garden, train my dog, and cure my dandruff.
I learned that most meteors burn up in Earth's atmosphere. Ah! The atmosphere! Ah!
The atmosphere! Ah!
Welcome to Short Planetary Geological Essays, narrated by Daniel Hutchinson. Martian Vesicular Basalt. So what is vesicular basalt? What does vesicular basalt have to do with Mars? Vesicular basalt is a dark-colored volcanic rock. The dark coloration comes from the predominance of iron and magnesium metals within the rock. The many small holes this type of rock contains are known as vesicles. A vesicle is a small cavity within the volcanic rock that was formed by the expansion of bubbles of gas, carbon dioxide, sulfur dioxide, water vapor. The gas is called volatiles. A volcanic eruption occurs in the first place because of decompressing gases within melted rock that propel the melted rock forward within a planet's crust, which then extrudes via a fracture, fissure, main pipe, etc. The cooled rock left afterwards is rock filled with holes, also known as vesicles, hence the name vesicular basalt. Vesicular basalt has been found on Mars, bearing a striking resemblance to vesicular basalt on Earth. Images of Martian vesicular basalt shows the same colorations as well as the same aphanitic, meaning microcrystalline, textures, and porphyritic, meaning large crystals within a fine-grained ground mass, textures. Thus, from the Martian rock images, it is reasonable to presume the mineral assemblages and volcanic history of these Mars rocks are like vesicular basalts on Earth. Further, all of this supports theories of plate tectonics, faulting, seismic activity, volcanic activity, and the past presence of water on Mars. In our solar system, basalt is a major component of the surfaces of Mercury, Venus, Io, the Moon, asteroids, as well as the Earth and Mars. The formation of a basaltic secondary crust, the partial melting of basaltic andesitic rock within a planet's mantle, is thought to be an important early heat loss mechanism for rocky planets, following the formation of the primary crust, which is the partial melting of a planet's upper mantle, by the earliest temporal initial differentiation. The surface of Mars reveals it to be a basaltic planet. The southern highlands appear to consist mostly of basalt that erupted between 3 billion and 4 billion years ago. The northern lowlands were resurfaced less than 3 billion years ago with either basaltic andesite, which is a slightly more silicate rock, or basalt that subsequently weathered. Vesicles in basalts may be interconnected or isolated, spherical or irregular or elongate, and sometimes displaying preferred orientations. The size and abundance of vesicles depends on many factors, including the composition of the melt and the style of the volcanic activity. Vesicles generally occur more abundantly at the margins of lava flows than in their centers. Flow morphology and internal structure can vary widely between different styles of eruption and emplacement. The upper crust of a vesicular basalt outcrop, having cooled rapidly in air, will tend to be somewhat glassy and highly vesicular, with the number of vesicles decreasing and vesicle size increasing from the top of the lava flow downwards. Meteoroid impacts can also generate vesicles in shocked target rocks. Although negligible on Earth, this may be a significant source of vesicular glass on the present-day surface of Mars. I hope you've enjoyed this short planetary geological essay about Martian vesicular basalt. Thank you for watching.